I hope you enjoyed these more relaxing videos. The next two videos are going to be a little bit longer. So let's talk about parallel and perpendicular lines. We already saw some example of parallel lines back in 153. Remember all these? What do they have in common? They all have the same slope. That's what we'll look at for parallel lines. I get too excited. I get ahead of myself. Two lines are parallel if they're increasing at the same rate. So their slopes are equal or the same. M1, the slope of the first line, is equal to M2, the slope of the second line. Perpendicular is a little bit weirder. Again, perpendicular lines, they might look like this and maybe like this. Parallel, gonna look like this. Perpendicular will look like that second example. Two lines are perpendicular if they form a right angle where they meet. This angle right here is a right angle. Well, all four of them are right angles. Okay. And so what does that say about their slopes? This one's a little trickier. And the reason for why this is the case is a little bit more complicated. But their slopes multiply to -1, which is not super helpful for all of you. But if you do a little algebra, you don't have to write this part if you don't want to, but you can. They multiply to -1, so let's solve for one of them. We could divide both sides by M2. And then we get that the first slope is just -1 divided by the second slope. So we say the slopes are negative reciprocals of each other. Negative reciprocals. I said reciprocal, the word was coming back. This is why. So if we have one slope, to find the perpendicular slope, you flip it and negativize it. Negatize it. You put a negative. Okay. And again, this is also the same thing as saying that the second slope is -1 over the first slope. So these are the same formulas. I'm just going to use one though. So example 6, find a line that's parallel to this function that passes through that point. Ooh, this is going back to last section, I think. First, we need the slope, and we already have the point. We know how to plot a line given a slope and a point. So if it's parallel to this, that means that it's going to have the same slope. Right? Parallel means same slope. So what's the slope of this line? The slope of the first one is 3. So the slope of our line that's parallel will also be 3. Because that's what parallel means, same slope. So now we need a point or a slope, an equation of a line that passes through this point. We know the slope, we know a point. Let's solve for b. We know y is equal to b plus our slope times x. And we know x is 3 when y is 0. Oh, that gives us our horizontal intercept. It doesn't directly give us our vertical intercept, our y-intercept, unless we plug things in. So y is 0, replace y with 0. X is 3, replace x with 3. And we'll get that 0 is equal to b plus 9. So b is -9. And we get our second line to be y is equal to b, which is -9, plus mx. Let's check our answer. Let's make sure both of these lines are parallel and that the second line goes through the right point. So if we go back to Desmos, 6 plus 3x looks like this. And the other one was -9 plus 3x. Are these lines parallel? They look to be parallel. Does the second line go through the point 3, 0? Oh, hey, look, it does. That's how we know we did a good job. Example 7. This is a good one to try it yourself if you want some practice. Maybe let's do the first one together, A together, and then you try B and C, which are harder. So the first slope over here is going to be 2. The second slope is going to be -1 over the first slope. It's the negative reciprocal. So it's going to be -1 over the first slope, which was 2. We'll just write that as -1/2. That's our answer to A. So you can really pause the video now and try B and C if you want, or we can watch it together. The first slope here is -4. The second slope that's perpendicular is going to be -1 over first slope, negative reciprocal. The negatives cancel and we get 1/4. Let's double check for both of them, right? Is this, if we flip it and put a negative, is it equal to that? Yeah, flip it, 1/4. A negative is a positive. And we could do that with the first example as well. Flip 2, you get 1/2. Put a negative, you get -1/2. Letter C, the first slope is 2/3. You can use the formula, or you can just take a shortcut. Flip it, now it's 3/2. Take its opposite, now it's negative. So let's do example 6 again. For example 8, let's do example 6 again. But instead of finding a line parallel to this that goes through that point, let's find a line that's perpendicular to this that goes through that point. All right, so if it's perpendicular, the first slope was 3. We got that from example 6. So our second slope will be the reciprocal and the opposite. And I said negative reciprocal over here, and that's true. If you want, you can also think about it as the opposite reciprocal. Because a negative times a negative is a positive. They mean the same thing. All right. So we find the negative reciprocal and we get -1/3. We could also take the negative reciprocal of -1/3 and get 3 back. If you flip -1/3, you get -3. Take the opposite of -3, you get +3. So it goes both ways. Anyway, so now we need a line with a slope of -1/3 that goes through this point. Well, our x value is going to be 3. Our y value is going to be 0. We know it's going to look like y equals b plus mx. So when is the y value 0? And m, we said, was -1/3. And our x value is 3. You can write it like this, plus a -1/3. But it usually looks a little weird, so I'm just going to write -1/3. So you get b, 0 is equal to b. This turns into a -1. 1/3 of 3 is 1. So b equals 1. Our answer is y equals -1/3, sorry, b, which is 1, minus 1/3 times x. Let's plot this and see if it's perpendicular on Desmos. Does it form a 90-degree angle? 1 minus 1/3 x. There you go. That looks perpendicular. Neato. All right. Try it now again. Find a parallel and a perpendicular line. Pause the video. Let's see if we get the same answer. We'll start with the parallel one. So the first slope, right, is just 2. So if it's parallel, our parallel line will have the same slope of 2. So it's going to look like y equals b plus 2x. We just need to find the b value. It's not -4. -4 is the starting value of h. But we're looking for a line that's parallel to this. that goes through the point 0, 0. Again, that's our x and our y. So y is going to be 0 and x is going to be 0. When you do this, you're going to find out that b equals 0. So our answer is just going to be y equals 2x. And again, I should really be clear about this and consistent. I didn't notice this. I apologize for not noticing it. Our independent variable, our input variable is t. So I should really be consistent over here and use a t here and a t here. We can still have y be our output if we want, but t is our input. They don't specify what letter they want as our output. They just say we're going to call it a function, h of t. But this is a different function, so this is a good way to write your answer. For perpendicular, our second slope is going to be the negative reciprocal, or the opposite reciprocal. The reciprocal of 2 is 1/2. Opposite of that, add a negative sign. So we know our line must be y equals b plus our slope, negative 1/2, times our input variable, which is t. And specifically, we know that t here is going to be 0. Right? It needs to go through 0, 0, so our t value and our y value are both going to be 0. We get 0 is equal to b minus 1/2 of 0. And again, we're just going to find that b is 0. Here, y is going to be negative 1/2 times t. Let's double check our answers. Let's plot negative 4 plus 2t. And let's see, is this parallel to this line? Yep. Does the second line go through 0, 0? Yep. The other one is negative 1/2 t. Also notice I didn't put the negative at first. If this were the case, no, these are not perpendicular. I forgot the negative. Once we get the negative, yeah, you can see they really just cross fully diagonally, 90 degrees between them. And our orange line still goes through the right point. We need it to go through the point 0, 0. And that's everything for parallel and perpendicular lines. You've got it now. We have one more video, I think, and then the extra practice. Bye-bye.